Welcome to my projectbazaar.com. Let us see about Pose-Invariant face recognition using Markov random fields. Pose-Invariant face recognition using Markov random fields. We provide a new method for reconstructing the virtual frontal view from a non-frontal face image using Markov random fields, that is MRFs. In this approach, the input face image is divided into a grid of overlapping patches. In order to improve the performance of our normalization method in face recognition, we also present an algorithm for classifying whether a given face image is first at a frontal or non-frontal pose. SVM classifier is used to classify whether the given image is frontal or non-frontal. This is the flow diagram of our system. It consists of 7 blocks. In load test image block, we load our input image, that is pose variant image, from the test images. In pre-processing method, median filter is used to remove noise from the input test images. It is often desirable to be able to perform some kind of noise reduction on an image or signal. The median filter is a nonlinear digital filtering technique often used to remove noise. Such noise reduction is a typical pre-processing step to improve the results of later pre-processing. Median filtering is very widely used in digital image processing. In page separation block, the filtered image is divided into pages by page separation method. Next block is feature extraction block. In this method, we extract the features values by feature extraction method, that is SIFT. Scale invariant feature transform is an algorithm in computer vision to detect and describe local features in images. Applications include object recognition, robotic mapping and navigation, image stitching, 3D modeling, gesture recognition and video tracking. Next is feature selection block. Feature selection is essentially a task to remove irrelevant and redundant features. Motivations for feature selection is to overcome the curse of dimensionality. The proposed DEFS, that is differential feature selection, highly reduces the computational cost while at the same time proves to present by a powerful performance. DEFS was introduced to solve problems with real values. After pre-processing stage, data passed to DE feature selection method. It prepares a subset with the best parameters. In classification block, we classify the image whether it is frontal or non-frontal by using SVM, that is support vector machine classifier. Support vector machine are supervised learning models with associated learning algorithms that analyze data and recognize patterns used for classification and regression analysis. In recognized image block, finally we got the recognized image by an Markov random field model. A Markov random field model is a graphical model, is a set of random variables having a Markov property described by an undirected graph. A Markov random field is similar to a Bayesian network in its representation of dependencies, the differences being that Bayesian networks are directed and acyclic, whereas Markov networks are undirected and may be cyclic. These are the source codes of our paper, and the main M file is a main program file. We have to run only this file only, and the remaining M files are sub function, and this is the test image and the training data are located here. We have to run only the main.m file only by right clicking and then run file. A new GUI window is appeared. Select the training data by pressing this push button. A new GUI window is appeared, and then select the train folder from this location. Train and then OK. Reading the training images, so please wait. After the training data are loaded, and then I load the images, test image by pressing this push button. Select the test image from the location. Select any one of the images from this location. I select picture 1 and then open. After selecting the test image, then I apply the pre-processing. In pre-processing, median filter is used to remove the noises from the input images. and then I apply the page separation. In page separation process, the input image is converted into number of pages. These are the pages output. Please wait a moment. The input image is converted into a number of pages. After completing this step, then I apply the SIFT, that is scale invariant feature extraction step. After that I apply the feature selection step. Page separation is completed. Then I apply the scale invariant feature extraction that calculates the corners. These are the pixel points of the input image. After that I apply the feature selection. In feature selection, irrelevant and redundant features are removed from the filtered image. These are the iterations of the feature selection algorithms. After calculating the feature selection, these shows the selected features from the image, and then I apply the classification. In classification, we have to find whether the image is frontal or non-frontal, and then we calculate the accuracy by in SVM classifier. We have to find the input image is non-frontal, and then press OK, and then we calculate the accuracy by pressing this button. The data classification shows the 100% accuracy. Finally, we get the recognized image by MRF, that is Markov random field model, by pressing this push button. This is the identified image from the input image. These three outputs are, this is standard MRF, that is standard Markov random field model, and the second figure is Gaussian kernel PCA, that is Gaussian kernel principal component analysis output, and the third one is identified image pixel points. From this I conclude that we finally achieve the best recognized image by using the Markov random field. Thank you.